Hello, welcome to another video where we're working on this thing called Odin's interpreter for the Z machine, which ran text adventures similar to this Zork game that you can see me playing and succeeding. Um, so this is kind of where we're at. I've done a bit more stuff off screen. Namely, I've added support for ANSI escape codes, so you can kind of move the cursor around and basically stuff to draw a status bar. And I've also borrowed some stuff from this library here, which is a slightly different license. It's a BSD2 clause where I'm using an MIT, I think, but I've put it in relevant source code and given the kudos where the kudos belongs. So I've been working off screen on this status line, and I think it looks pretty good. So it's not here now, but if we quit the game, you might notice it looks quite like props in terms of the header up there. But this has an issue that if you like resize the screen, it's just you can't kind of get it back looking right once it starts doing a few things. And yeah, it's just it doesn't quite work if you resize. Whereas my one, I not edit that file. If we run this, I believe we should be able to resize at will. It doesn't. Well, I say that, but it'll actually kind of cause issues when I use some flags like the status line flag. And here we can see a status line up the top that looks kind of similar to thing. But you'll see here it doesn't kind of redraw that status line after you resize it like that. And I didn't mean to do that. And if you kind of resize it that way, um, you can go back here. It will think the width is twice as long as it is, just because that's what it sees. And when you reset it, it's kind of fine. So I guess I just wanted to kind of show that off and then maybe look at finding the next thing to do. So I've got a few inputs. If we have a look at what do I have? I've got uh, input drop egg. So I guess I can walk through that slowly. If we go into this, we can actually make it a reasonable way. You saw in that last kind of playthrough, not open, take egg. You saw in that last playthrough, I like kind of got into the house and walked in. You can do a bunch of stuff, and in this, I will kind of walk through some of the stuff you can do and can't do at the moment, and then decide what to work on. But yeah, if you drop the egg, it errors out on an unimplemented code. And I've added some debugging to kind of show a bit more stuff that's going on with the unimplemented opcodes. The first thing is it will actually jump to the line that you're meant to change. So I'll be changing this unknown. And it also kind of shells out to TXT to basically say this is what TXT says for this address. And then I can kind of come here and look at this dictionary and see what it is. So if I just search remove object, we can see it's 10137, which is the same. So that's one thing I could do. And it's kind of similar to the object things I've been working on. So potentially I will look for another thing. Um, so if we kind of go back into the house, and on the wall here there's a sword and a lantern. Now, interestingly, you can take the lantern, but if you try and take the sword, it needs another opcode, which is get next prop. So we could do that. Get next, yeah, that one, and that's 2op19 and 2op19. So we could also get this one, which is probably also reasonably straightforward. Or we could also do, I think this used to error out the quitting, but now it does not. And another one that I saw was if we go into the house and then try and go down the window. So this is potentially an interesting one because it shows kind of a, I don't know, Easter egg, but it's not really an Easter egg in these sorts of games. Like, they have a lot of random stuff you can say. In fact, I could probably start saying random things and I'd find other crashes like this. But this one's a load, which is probably quite simple to do. 10142, and that's the same. So here we just need to the value of the variable referred to by the operand is stored in the result. So I guess I mean, the TXT output kind of suggests that it is loading a byte from that address. But this word is like, I don't know, because it could be the variable, because the value of the variable, I would say, is the value of the variable, not the value of the data pointed to by the variable. But I don't know, it is what it is. Interesting one. So that's one that kind of says something like, you're not Santa Claus. But one that is kind of interesting that I have left to last purely because it is kind of random. So open track. So you can actually take lamp and turn on lamp and go down. You can go down and you can have a look at the X, have a look at the troll, and like if you try and do stuff, it gets a stack underflow. So it's trying to read a variable that it is not what is expected. Which that isn't so good because that kind of means that we have, yeah, we basically run out of a stack. So what are we meant to read? And was it a bug or something else. But yeah, it is kind of interesting because it kind of depends on the randomness of um, uh, randomness of the fighting mechanics. Always got to take your lamp. Um, Lights. Because yeah, sometimes you might just do something, and that's like another load code. So yeah, there's a few different opcodes that could be kind of interesting to look at. This load one is kind of interesting, but the stack underflow is also kind of interesting. So I guess this is also kind of good point to input throw. Um about this. Um this could be a good point to nah, I don't want to do that stuff. And this can just be that. This could be a good point to kind of talk about the options that exist now that you can kind of run. So there's a bunch of like kind of trace type things, and based on whatever you want to do. So you could do like a backtrace before every instruction, and it'll kind of say what address you're at and what the stack trace is at any individual point. Or you could do like the current frame that you're on, and they'll kind of show what things look like. And this one could be kind of interesting to look at if we do the input troll whip on this. If we do this one, we should at some point see, yeah, so it has that stack underflow. And we can see that it does have the stack full at some point. Well, not full, has something in it at one point in this routine, but there's like another routine that calls that, or this could be another one. You don't quite know, but there are other ones like we can do by instruction, and it will print out basically the instruction listing that we had quite a while before. But this one now, because we kind of print stuff out at the same time, it the output kind of looks a bit funny. So that's that. At some point in the future, I might have it so you have like multiple windows, kind of like you've got in Tmarks here. Like these are multiple windows that you can kind of move about. Um, and like in those windows, you might have one that has a debug listing of like all the opcodes that will be run, and like then another window might show the objects that you're looking at and what properties they have. Because I think that could be kind of useful, and potentially the ability to change the code as you go, but that might be a bit trickier. Um, so what I think I want to do is pick one of these things to look at, and I think I would be kind of interested in having a look at potentially just all here. There's like another shorthand which is just trace all. It does do the reads and writes, which can be a bit annoying, but yeah, I think I might just do the trace all, and I'll input this troll weapon list. And so this will kind of just read from that script and it'll run the code as you do, and it should hopefully hit this unreachable statement. And it shows, yeah, we want to read from the stack and it doesn't exist. So what we can do is maybe if we go something like here, and we can see kind of what's been happening in this. And we could maybe even have here txt, and we could have a look at what this function is doing. db1, so that exists somewhere. So it's a reasonably large one. It looks like it is the function that deals with trolls. Now this is interesting. We have a different thing here. So this is saying it's jump greater than, but we had sub. So that could be the cause of what our issues were. I think I want to do, I think it was minus A. That wasn't minus A. We can just run it. It was minus D. And if we find that same one, yeah, so the memory is not the same as what it is there. So I wonder if we've actually written to that location at some point. So we could probably search that. We can that's that one. Have a search for right at ff db or d1. I mean, nothing's written to it. Yeah, I wonder why it is a different digit there. Or have I got? Ah, yes, I do. Man, I was getting. It is. Come on. Actually, FB. FB. Gosh, geez, D1. And that should exist somewhere. And that's a sub. Cool. And it is still kind of a battle with a troll. So it's a reasonably long thing there. And in it, the so we have a call. Yeah, we've got a calls in places, and we should be kind of adding to stacks at some point. So I guess like one place to start is maybe just going yeah, I think I don't want to have everything, but I'll have the instructions and I'll have the frame, and I'll just have those two. So that would be just this line and this line. So I won't have the backtrace and I won't have these read writes because I don't think they're helping the situation. And this will be a lot more concise and hopefully help aid see where the stack gets written to and from. Do, do, do. Yeah, so this thing that we ran a random and it's meant to save to the stack pointer, but it didn't put anything in. So that looks like an issue just there. And I wonder if we, in like, it would be in execution. Well, actually, it might have just been where I was right variable. Yeah, because we are writing variable everywhere. And what do we have in random? We also have a write variable. So we are doing something there. I don't record things. Do that and have a look in this. So if we are writing a variable, we just write to the stack. Which looks like it should do the trick. Maybe I do want those reads as well. So maybe I'll get the trace reads and trace writes, so I won't have the back traces, but I still will have a reasonably large stack trace. And here we can kind of have a look. So this stack pointer, it wrote not to the right thing. So it wrote to LO2 instead of writing to stack pointer. So that seems like an issue. And same here, it's meant to be writing to a stack, but it wrote to LO5. Oh no, write to stack. But here it didn't. So why did this write to stack and this not? So I guess that would be why. Right, so where do I use this current frame dot store? Yeah, that's only really if you are returning. Right, so it looks like it was just random that was doing that. So um, probably just have fixed what the issue was. So we can go and rest and what do we need to get? Take this lamp, light it up, move the rug. In fact, I might do this all with the status line just to test it out. So it's updating the moves and it's updating the location. And we got some points. Move right, open, crap. Yeah, and we're getting heaps of points. Cool. So that was just an unimplemented opcode. Cool. I'm happy with that. fixing bugs. Right. And I wonder if that was done anywhere else. Nah, look pretty good. Look pretty good. Cool. So I guess which thing should I look at first? I kind of want to be able to pick up the sword. So I might do that. Input sword, get sword, because that's kind of like iconic. So 2 up 19, get next prop. Have been doing a lot of object stuff, but I wonder. Yeah, well, let me do this because it's in the quick fix list. And so we'll probably need to. Where's N come in this? Right, so get next prop. Get next prop. Prop is there. Where'd you go? Here. Right, so it gives the number for the next property provided by the quoted object. Maybe 0. And if it's called with 0, then the first property number. That kind of makes sense. So if we don't really need this anymore, we'll kind of maybe do later on, but for now I'll get rid of it and swap to the object table. So the objects are kind of stored with these properties, and the properties are kind of listed in they're in order, so you can kind of see how they go. Um, and here's kind of some examples. So what we could do, and we have a way to kind of search through the properties. But what we can do is basically do that binary search to find where it should be. Well, where the current property is, then add the next thing, and then find out if that is there's an end to this. I think it will. It surely must finish at some point. Yeah, size byte of 0. So we can just kind of go through and do this. I just out of interest, I want to see if it will. Yeah, you can say stuff like that. Oh, and you can't say hi. Oh well. Deck was another one that was there before, but anyway, enough of that. Um, what were the things here? Uh, use the mouse. Right. So get next prop. It's 2 and it had a return, so it doesn't need a branch. Get next prop. And it does need a store. We'll come back to that one. Right, so we did a make on this. I assume we could. Do that. And here we probably want to do the same. Go back there, and this has a code. We actually have it there. Cool, and we'll just put in a safety unimplemented for now. So this probably doesn't need that. That was only kind of for, yeah, get next prop. Right, so we have two instructions, and property, that's going to be that, and properties have to be there's only so many that you can have. I guess you can only have 32 properties there. And a bit more, 64 properties there. I think probably won't do any asserts there. We'll just do that assert. So probably just have like a method for this. Something like that. And we can just call it next and next here, and probably go and make that object next prop. I don't know where best to put it. Well, this one's probably a better header to do. Next property, we'll call it that. Right, and what is this going to do? I guess we can just get the address and here we can do something like this and also get this. Just because we'll deal with that when that comes. Because at the moment we have the property address from uh, get property address, which helpfully gets us this address here. So we can go one back and get the size by it. And we should probably do something like this. And what we can do is find the length, and once we find the length, we can probably do like an assert because you get the prop num. We don't need to do an assert. I'm over asserting there. Right. But once we get the length, we can get another size byte. And it's going to be machine read byte, and it's going to be oh, we just pass in the address. Um, we'll call it that. So if we get property address and we add length to it, so we are at this point and we add the length, which should be like if it's we want to add the length from there to get there. So I guess we want to get the length -1 again. And here, if this equals 0, we wanted to return a thing. We just return 0. Otherwise, we get the property number, which will be this. And then we can return prop num. Something like that, I think. Um, didn't like that. But if we make that it doesn't like that. Yep, because we've done it now. Cool. We have taken the thing. We still haven't unimplemented. Oh, yeah, that's easy. So we need to return 0 there. So, false. shows us how to do it. We don't have it there, but we do have it there. So cool. We don't need to do that. And that. So now it should give an IO error, and that's cool. That just means that we've like run out of input, which shouldn't normally happen in a terminal, like an interactive one. But with these text files I'm posting in, that will happen. But yeah, now can get the sword. So just implemented like one instruction really. I will just take one thing out of here. Restore stage. Forget which file was in. That one. Just do that. Just because that's like not quite for that instruction. So what do we had here? We had get next prop. And here it's get property length, and I just want to check that. Yeah, get property 0 len must return 0. It is required by some infocom games, which I guess is what's happening here. So get commit return false if get len 0 is fraud. Easy. Cool. And so now, I guess we probably have a kind of. So one thing I noticed with my status bar is it has like kind of a flickering effect. So I guess I'll probably look into how to not have that. And it's basically redrawing the whole line, which I wonder if that's the most efficient way because it is a reasonably long line, I guess. And I want to have it so there's like buffer space in the right places. The score can go up to like 1,000 and the moves can go up to like 10,000, I think it is. So needs to be able to fit that many digits. Though I guess it doesn't need to. Yeah. Yeah, it's, I don't know, interesting. But anyway, now I can take all three and maybe move the rug and open trap and oh maybe we can kill a kill troll with sword. We need to take our sword. Yeah. Missed that last one. I'm kind of like read line type ability as well, so you can kind of push up, or control P is also kind of up one line and bash. Well, read line. Because yeah, now I have to kind of write the kill troll with sword again. Cool. Do it again. And yeah, we can't like kill him because I thought it did remove objects already. But yeah, anyway, there's like more opcodes I can go and do now, but now we can pick up a sword and like kind of move about and do some stuff. It's kind of cool. And I wonder if you can, yeah, you can do some stuff. Um, yeah, you can like buy, you can say certain things. I guess something like this. Except maybe change that to A. So in here there will be like some words that kind of have a meaning. Um, but potentially they don't, like a lot of them don't, they're just kind of text. Yeah, maybe it's a different place. I don't know. I think I'm just rambling now. And I think that's finished. So yeah, I think that's probably good for now. I'll push that up and can pick up swords and do running things, so that's pretty cool. But yeah, for now, thanks for watching the video, and if you enjoyed it, let me know, and see you next time.